A quick video on how science works in terms of collecting reliable evidence and valid evidence. And by the end of this video, you will know the difference between what reliable means and what valid means. And for this video, it will help you preparing for GCSE, but also for younger students in years 7, 8, and 9. This will be useful to go through so you know the difference. So whenever you're doing an experiment, you need to make sure any evidence you collect is first reliable, and of course it's also valid and relevant. Okay, so the learning objectives are to understand the meaning of data and evidence, and also to know what is meant by reliable and what is meant by valid evidence, and they're different. Okay? And you also need to look at what they mean by secondary evidence. If you're investigating something, you shouldn't just rely on one source of evidence. You need to make sure you have more than one source, and that secondary source should back up the primary evidence that you collected. Okay, so some definitions. I apologize for the sound effects. Yet again, that was even more annoying. So data, evidence, reliable, valid, what do they all mean? This is what this slide is for, just to make you think. Okay. So data, first of all, data is plural, it's not singular. So when you have data, it's not a single measurement, it's all your measurements together. So you put all your results in a table, all of the results in a table is your data. Okay? So data is already plural. For example, when you read a thermometer, the temperature readings, all of them together, are your temperature data. Okay? So here's temperature seems like it's cooling, 70, then 68, 66, then 64. We don't know the context, but they're just giving you a set of data which is more than one. Okay? So data is plural, and strictly speaking, if we want to know a single piece of data, the word would be datum. Okay? So I think it comes from Latin. So definitions, what is evidence? Well, evidence is data which is judged to be relevant to the purpose of your experiment. For example, when you want to investigate cooling, obviously temperature is relevant, and you need to collect the temperature over time to see that it's cooling as expected. So temperature would be considered relevant evidence. Okay? So the data is relevant. The length of the thermometer is irrelevant or not relevant, because the length of the thermometer has no bearing on cooling. We just want to investigate cooling. What you need is temperature and time. So length of the thermometer is not relevant, so it's not evidence. It may be some information, but it's not necessary for a cooling experiment. Okay, so definition of evidence. Evidence is data which is judged to be relevant to the purpose or the aim of the investigation. So evidence needs to be reliable, yeah, and valid. So we need to now discuss what is reliable and what is valid. So reliability is to do with evidence that can be trusted, okay, in terms of, have you measured it accurately or precisely enough? Yeah. So if someone else did the same experiment, would they be able to get the same results as you did? Okay. So we often call this inter-observer reliability. That means if more than one observer did the same thing, would they get the same result? If the answer is yes, then the data is considered reliable, and you can trust the data more. Okay? So your evidence will become more reliable if you repeat your readings with the purpose of averaging them and taking the middle value or the mean value of the data to get rid of any possible random errors that might come in. It could be because of human error, for example, misreading the scale, not having your eyes level, for example, with the scale. If you're measuring, for example, the length of something, you've got to make sure you're perpendicular to the measuring instrument. So you're right near where it is. Often with the meniscus, for example, in measuring volumes of water, you should measure to the bottom of the meniscus because it kind of curves up the sides of the glass instrument. Okay, so here's an example of reliability. 3 students want to measure the time for a swing of a pendulum, and a pendulum is just a mass that goes backwards and forwards. Okay, it has a regular time, but if you want to measure it in a reliable way, you've got to think of the best way of doing that. So if Joe measures one swing, she will have a large uncertainty in her measurement because the time to start and stop a stopwatch is due to human error if you're doing it manually, and that will be a large uncertainty. Whereas if Emma measures one swing but then does it 20 times and calculates the average, it might make it a little bit more average in that the end results, the outliers in the data can be ignored, and you go for what is the middle value or the mean value of all the 20 measurements you took. So it would be an improvement, but you still have the problem that starting and stopping the stopwatch is a human error which can either be done and make the result higher than it should be or lower than it should be. Okay, so these kind of uncertainties cause a problem with reliability and how much you can trust the data based on your method of measurement. Okay, so you want to try to reduce any random uncertainties. So a third method would be that Jack measures 20 swings, so he only has the uncertainty of starting and stopping the stopwatch at the beginning and end of the 20 swings. So it's spread out, that uncertainty in knowing exactly whether he started the stopwatch the same time as the swing started, and stopping it at the end of the 20. It only happens 1 in 20 times, whereas Emma's method, it happens every time. So which method do you think would be most reliable and why? Okay, so this brings in the concept of random uncertainties in measuring, which is also a problem. The other thing that they haven't mentioned here is if you're measuring the pendulum going backwards and forwards, you should make sure you have a reference point to when a swing starts and when it finishes. Okay, so what I always teach my students is measure from the end where you were starting, and it has to go there and back again for a complete swing. Okay, so reliability is how do we get rid of any unwanted uncertainty in the way you do it. Validity, on the other hand, is actually being sure that what you're measuring is what you thought you were measuring. So for younger students, this is simply put in this way. Valid data is evidence that is reliable but also relevant to the question being investigated. If what you're measuring is not relevant to the question being investigated, it's not actually worthwhile. Okay, so validity is will it actually answer the question of the main aim of your investigation? If what you're measuring doesn't help you answer the aim of your investigation, then it's probably the irrelevant data that's being collected. Okay, so just being reliable is not enough. You also need to make sure you're measuring the right things to get the answer to your investigation question. So the evidence then would be relevant as the examples that we could give. For example, here they discuss which of the following is valid evidence. If you want to measure the length of a magnet to decide its strength, that would not be relevant because the length of the magnet does not necessarily have anything to do with its strength. So it would be considered to be not valid evidence, and it would just be set aside and should be ignored. But because a long magnet can be strong or weak, and so can a short magnet. Okay. So here's a second example to do with validity. And now you've got to think, in this second example, which of the following is valid evidence? So measuring the extension of a spring to find the pulling force on it. Well, for those of you who've done Hooke's law, you'll know the greater the force pulling or stretching the spring downwards, the weight is what is directly proportional to the extension. So measuring the extension is valid evidence for investigating force and on a spring. Okay, this is called Hooke's law for those of you in years 9 and above who've done it before. Okay, here's another third example of measuring the validity. So if you measure the volume of a firework to find out how much energy is in it, would that be valid? Okay, you could assume that the bigger the volume, the more chemical is in it, and you might think that it would be valid, but it probably isn't valid because it depends on what the chemical inside is. A large or a small firework can have a lot of energy or very little energy, but it mainly depends on the chemicals inside. So the volume alone would not be considered relevant, and therefore it would not be considered as valid evidence. So secondary evidence is when you want to be sure that the evidence that's been collected is valid and reliable or not. And the example that they're given here is someone else has given you data. For example, you might find it in a book or on the internet or like Wikipedia. But for example, on the internet, the Wikipedia, anyone can edit it. So it could be inaccurate or it could be wrong information that someone has uploaded on the internet. So you always need to make sure you check and double check and triple check the sources of your evidence that you're citing or using. But you should always make sure it's both reliable and valid. Okay? For example, secondary evidence is data collected by someone else. Example one. Oh dear, that noise came back. Some data on the pollution of a car. If it's published by the manufacturer, how can you trust if that evidence is valid or reliable, or both, without getting further evidence? Because obviously the car manufacturer may be biased and want to publicize their vehicle as being low pollution to sell their vehicle. So that, to me, would be an uncertain way of checking the validity of the claim. The other one was, for example, during the recent lockdowns, we had pharmaceutical industries, for example, saying that the treatments that they were asking people to take were safe and effective. And it's turned out since then that they were neither safe nor effective, and a lot of people have had complicated side effects as a result. So that would require an independent body to ensure that the evidence can be trusted. So you always need to make sure you, what we call, triangulate the data, so get it from 2 or more sources. And the more independent the sources, obviously the more reliable and trustworthy it will be. Okay? So, for example, if a mobile phone company is giving data on the radiation emitted from their own phones, would you trust that data? Yeah? So again, it's the same example I gave you before on the previous one, and the one that I gave you as my example. Yeah? You have to make sure that you have independent studies done, and I think that sometimes the industries want to be self-correcting, so you always have to be wary of the data that they give out. Okay? So learning outcomes, this is what we've learned from today's quick video on science skills. So the difference between data and evidence, yeah, what is meant by reliable evidence and valid evidence, and what is meant by secondary evidence and evidence that is trustworthy. So I hope you found that useful, and if you did, please make sure you like and share the video with any friends who are doing the same course as you. This is useful for anyone doing any science, any subject, and really in any year group, and it's an introduction to GCSE standards. If you do it at A level, it'll be more like the examples I gave you verbally during the video. So feel free to stop the video at any point and make notes for yourself, and they will ask you about data generally in GCSE exams in particular, and ask you to comment and criticize the data. Okay, things like number of decimal places used, things like that will also be more detailed versions of looking at data. Okay, well, please subscribe to the channel if you want more videos like this. The more likes and shares and subscribes I get, then subscriptions I get, the more likely I am to make more videos for you. Thanks for watching. See you in the next video. Bye for now.